Tom Gowland. I'm a developer on DAFNI, and I've worked on DAFNI for about the last 2 years. And I also joined Beth in a technical leadership role and do some product ownership as well. So I'm going to show you the modeling side of the platform today. So we'll go through the process of uploading a model and then running that model, and I'll sort of talk around that as we go. So you need sort of two things to upload your model onto DAFNI. First of which is this YAML file, which is just, it expresses the metadata about your model essentially. So you can see things like description and summary, the title that other users will see, links to your GitHub page for your model and that kind of thing. But then you've also got more complicated things like what actually goes into your model to be able to run it. So in this case, we've got, this is actually the COVID-19 COVID sim model, which I believe is Imperial, actually produced by Imperial, so based on Neil Ferguson's model, underlying model. So the whole point of this is basically to input a country name as well as an R number, and then a couple of other factors, and then it will simulate the COVID-19 pandemic and tell you a load of details about it. So it takes in these parameters that a user will be able to change, as well as outputting these data sets at the end. So they've got brief descriptions associated with them. And the other thing that you need is a containerized image of your model. So for that, we use this technology called Docker, and Docker is basically just a way of packaging up your code and then shipping it off to us, so that when we unpack it at the other end, it runs in the exact same way for us that it does for you. So you can be assured that your model runs the same way on DAFNI that it does on your local machine or wherever you've been used to running it in the past. And a Docker file just kind of looks like this, so I won't go into too much technical detail here, but essentially you set up a base operating system so you can make sure everything's the same from the very start. You install a load of packages that you need. Here I clone the repository of the COVID sim from GitHub, and then do a load of other stuff, install everything that I need, and then finally at the end I run this wrapping script that I wrote around the COVID model. And all that does is inject some variables at runtime in the way that we expect. So if I go across to here, this is what the repo actually looks like. I don't know if many of you are familiar with this repo, but I think to a non-technical user, this would be quite complicated if you were interested in getting some results out of a COVID-19 model. It might take you some technical experience to be able to do that. And also, it's not really very runnable on a desktop machine, so it takes about 30 gigabytes of RAM to run for the whole of the UK, which most people wouldn't necessarily have in a desktop PC. And equally, it takes quite a long time to run on a desktop PC. So I wasn't even able to run it on my local machine for the UK, but then I ran it for Hawaii, which is obviously a much smaller place. And that took something like an hour to run. And so DAFNI can help in both of those respects. So we always got a load of hardware behind the scenes that can help you run this stuff. But also once someone's actually done the technical job of containerizing that model and uploading it onto DAFNI, then any non-technical user can come along and run it in what we hope is quite an easy to understand way. So I'll show you the process of uploading a model. So we're back on the DAFNI front page now, and I can go into models. And this is where you, as a user, would come to browse the models that are available on the platform. Most of these models have been uploaded by people, actual users on the platform, which is really nice to see. But some of them are like test models that we've uploaded as well. So you'll see that I've already uploaded one earlier today, and that's just because the upload time we probably don't want to wait for in this meeting. So go into add a model. I can then browse the documentation that we've got available, so I can go across and read how to structure that definition file. I can read how to containerize my model, and there's plenty of useful tips, and we've got loads of examples as well on our GitHub page that you can refer back to if this is your sort of first time doing a Dockerization. Once you've done all that, you can browse the files on your computer. I've got the YAML file that I showed you, and then this tarball image, which is essentially just the Docker image, but compressed so that it's a bit of a smaller upload. And then we add that model. So we could wait for this to upload, but obviously it's a bit boring, so we will go across the one that I made earlier. And so this is what it looks like when you browse to the details of a model on DAFNI. So these fields are all filled out based on the contents of your definition file. You've then got a load of input parameters which have some nice tooltips to explain what they are for. and then you can get an idea of what's going to come out of the model once you actually go ahead and run it, which we will do now. And it's important to note that in the same way that data is not available as to everyone as soon as you upload it, it's the same for models. So this is only actually available for me at the minute. I could choose to share it with other people if I wanted to in the future. So I go across into workflows, and this is where you actually come to make use of these models and actually run them. And you can see that there's plenty of activity on the platform at the minute with people running workflows. So we're going to create a workflow. We'll just not bother too much with the metadata, build the workflow. So now we've got this quite nice interface where we can see our workflow steps. And at the minute, we've obviously just got a start and end step. We need to add some stuff to actually do some stuff, basically. We've got 4 different step types to choose from. So iterated step types are just a way of iterating over the same model step multiple times with a varying parameter. So you might choose to vary on R number in this case, and you could then do a sensitivity analysis to say how much does R number affect the number of deaths or whatever. And all of that happens in parallel. So if you choose to run 100 different R number iterations, they'll all run in parallel on the back end. So you should get a result out fairly quickly, depending on the resource available on DAFNI at the point of running it. We then got a modeling step, which is probably the most important type of step, and we'll add one of these now. So we select a model from our previous list. So COVID-19 COVID sim, which is the one I uploaded earlier. Select that, and now my parameters list gets populated down here. So I can choose from a range of different countries. I can change the R number, so we'll put it to 1.8 in this case. You could change the percentage of people that are complying with quarantine and how long the government are recommending to isolate. There are loads more parameters available on the model itself, but I just ported a couple of them across to give a sort of flavor as to what you can kind of do. I'll create that step. And now what will happen on the back end when we run this is that model step will run, it'll produce some output, but then we need to put that output somewhere. We need to do something with it. So we've got a publish step, which if I click this, it just has the exact same metadata form that Bethan showed earlier. So a user would fill this out in the same way that Bethan showed. And once the modeling step had finished, the publisher step would then upload all of your output data into the data catalog, and you could then browse to that and share it with other people from there. But you have to obviously fill in this metadata first. The other kind of step we've got is a visualization step. So in the same way, you would fill in this metadata because the data still gets published to the data catalog at the end, but it also has the extra benefit that it spins you up a visualization of some description. At the minute, we only have Jupyter Notebook type visualizations available. So for those of you that are unfamiliar with Jupyter Notebooks, it's essentially a sandbox environment where a user can come and write some code to do some post-processing on their data and then maybe draw some graphs from there. Obviously, we understand that a lot of the point of DAFNI is to make it so that these models are accessible for non-technical users. So we're currently working with Oxford University to produce a drag and drop tool, which will help users visualize their data much more easily and without having to write any code as well. So if I wanted to create this visualization step, I'd select this, fill in a step name, fill in this metadata, and then create the step at the bottom. But Bethan's already shown that really well, so probably no point in us doing that again. So this was a completed workflow that, again, I ran earlier on today with the model step. The R number is actually set to 1.7 here, but that doesn't matter too much. And then our visualization step at the end. So you can see that both of these have ticks on, which means they've completed successfully. So you can click visualize on this final step, and this will take us into our Jupyter Notebook. And all of our data has come out. So you can see these Excel files, I think they are, that have been spat out of the model. And so they're obviously all in there, but a bit hard to get your head around just by reading through the Excel files. But if we go back a couple of steps, I've created this R script essentially, which again is just taken directly from the COVID-19 GitHub repository. And essentially this draws some nice graphs using the output data from the model. So you can see how you could write this code. A user would come, they finish their modeling, they run this script, and they can get some nice graphs out of it. And this again is something that we're actively working on so that you could then export all these graphs into DAFNI, and then you could share those base plots with people. So if you didn't want people to go all the way through the visualization to be able to produce these graphs, you can actually share these individually as plots, and we'll have the same kind of exporting tool available in the drag and drop interface as well. So that was kind of all I wanted to show on the modeling side of things, but I'll happily answer any questions.